guys, at the request of my students, we're going to do a volume of known cross-section. Let's first graph the base. It says the base of the solid is the region enclosed by y equals e to the negative x. Graph of e to the x, you guys, I saw this, it's so cool. Take your right hand and look at it. This line up here is going to be the graph of e to the x. This is the graph of ln of x, and then right in the middle would be the graph of y equals x. So it's a nice little way to remember each graph. This says negative x in the exponent. So a couple of things. If the negative is in front, then you can put your arm in front of the function and you're going to reflect across the x-axis. But if the negative is up inside next to the x, it's going to reflect across the y-axis. So here's our e to the negative x graph. Next, it says the coordinate axes, so that's going to be the x-axis and the y-axis, and then finally the line x equals 3, the right bound of your region. So here is the base of our region. It says if all plane cross sections are perpendicular to the x-axis, so whichever axis you're perpendicular to, that determines whether your integral is going to be a dx problem or a dy problem. So since we're perpendicular to the x-axis, this is in fact going to be a dx problem. The formula for doing a volume of known cross-section, it's going to be the integral, go from 0 to 3. And then your formula is a of x dx, where a of x is the area of the shape of the cross-section. So our cross-section is a semicircle. The area of a semicircle is 1/2 pi and then r squared. Perpendicular to the x-axis, I'm going to draw kind of like a line right there, perpendicular. And then what's happening is you have these semicircles coming out of the graph. And I'm going to kind of draw this up here, but if you had a semicircle coming out of the graph, you'll notice that this here is the same as that, and that would be the diameter of your semicircle, and that is the height of this function. So you get e to the negative x is the diameter. We need the radius, so we're going to do half of the diameter. It's going to be e to the negative x over 2. So now we're going to integrate this. We're going to pull this 1/2 pi to the front, be e, and you're going to multiply those exponents to get negative 2x, and then 2 squared is going to be 4. We're going to pull this 1/4 to the front, making this 1/8. And now at this point, we have different ways we can do this. I'm going to do substitution because I just want to practice with some of you guys substitution with a definite integral. You could totally just do the integral in your head and jump straight to negative 1/2 e to the negative 2x if you would like. And we have 1 minus e to the negative 6. So that means our answer choice is C. All right, guys, thanks for watching.